In this video, we are going to learn how to find determinant of matrices. You already learned how to find the determinant of 2 by 2 matrices. So let's say we have matrix A equal to A, B, C, D. So the determinant of matrix A is equal to AD minus BC, where we multiply the entries in the first diagonal minus the entries in the second diagonal. Okay, let's look at the example. Determinant of A is equal to 2 times 8 minus 5 times 3, which is equal to 1. To find the determinant of AB, first we have to find what is the matrix AB. So 2, 5, 3, 8 multiply with the matrix 3, 2, 5, 2, we have 6 plus 25, 4 plus 10, 9 plus 40, and the last entries will be 6 plus 16. So it is equal to 31, 14, 49, and 22. So the determinant of AB is given by 31 times 22 minus 14 times 49, which is equal to -4. Okay, there is another way how to find the determinant of AB, where we can use property. Determinant of AB is equal to determinant of A multiplied by determinant of B. So we already have the determinant of A, so we are going to find the determinant of B. Determinant of B is 3 times 2 minus 2 times 5, which is equal to -4. Therefore, determinant of AB is equal to determinant of A multiplied by determinant of B, which is equal to 1 times -4, which is equal to -4. That. To find the determinant of 3 by 3 matrix, first we have to know the definition of the minor and the cofactor. The minor, symbol Mij, is the determinant of m minus 1 by m minus 1 matrix, obtained by deleting the ith row and the jth column of the m by m matrix, where the cofactor with the symbol Cij is given by -1 to the power of I plus j multiplied by the minor. Okay, let's look at example 4. Given matrix A, where matrix A is a 3 by 3 matrix, find minors and cofactors of the element A11, A21, and A12. So let's look at the solution. Minor of the element A11 is M11. So M11 is the determinant of 2 by 2 matrix, because we are going to delete the first row and the first column. So when we delete the first row and the first column, the remaining matrix will be 4, 2, 4, 3. So the minor 11 is 4 times 3 minus 4 times 2, which is equal to 4. Cofactor of A11 is equal to C11, which is equal to -1 raised to the power of 1 plus 1 times minor 11, which is equal to -1 to the power of 2 times 4, equal to 4. Okay, minor of A to 1 is M to 1, which is equal to the determinant of, we are going to delete the second row and the first column of the given matrix. So when we delete it, so we are left with 2, -1, 4, 3. So the minor is 2 times 3 minus -1 times 4, which is equal to 10. So the cofactor C to 1 is equal to -1 to the power of 2 plus 1 times minus 1, which is equal to -1 to the power of 3 times 10, equal to -10. Okay, minor of the element A12 is M12, which is equal to the determinant of the matrix. We delete the first row, second column. So the remaining matrix is 3, 2, 1, 3, which is equal to 3 times 3 minus 2 times 1, which is equal to 7. And the cofactor, okay, the cofactor of 1, 2 is equal to -1 to the power of 1 plus 2 times minus 1, 2, which is equal to -1 times 7, equal to -7. The determinant of a matrix A with the dimension n by n is obtained by summing up the product of each element of certain row or column by its cofactor. So, the determinant of A is the summation of the product of the element multiplied by its cofactor. Okay, let's look at example 15. Given a matrix A, 3 by 3 matrix. Find the determinant of A by expanding along second row, B first column. Okay, let's look at the solution. For question A, we are going to expand along the second row. So here is the second row. So the determinant of A is given by A21 times C21 plus A22 times C22 plus A23 times C23. So the element in the second row, first column is 1. The cofactor, so the cofactor, remember the definition, it is equal to -1 raised to the power of 2 plus 1. Multiplied by the minor, where we are going to delete the second row, first column. So the remaining matrix will be -1, 4, -1, 10, plus A22. A22 will be -2, multiplied by the cofactor, -1 raised to the power of 2 plus 2. And we are going to delete the second row, second column. So the minor is determinant of 3, 4, 5, 10 plus the element of 2, 3, that is 7, multiplied by its cofactor, -1 raised to the power of 2 plus 3 times the minor. Minor, we are going to delete the second row, third column. So we have the matrix 3, -1, 5, -1. So simplify this, we will have -1 multiplied by -10 plus 4 plus -2 times 1 times 30 minus 20 plus 7 times negative 1 times negative 3 plus 5. The answer is negative 28. For question B, we are going to find the determinant of A by expanding along the first column. So, the determinant of A is given by A11, C11 plus A21, C21 plus A31, C31 because we are using the first column here. So, the first element is 3 multiplied by negative 1 to the power of 2 multiplied by the minor. The minor is, we are going to delete the first row, first column, so we are left with negative 2, 7, negative 1, 10 plus the element in the second row, first column is 1 multiplied by negative 1 to the power of 3 multiplied by the minor. The minor, we are going to delete the second row, first column, so we have negative 1, 4, negative 1, 10 plus the last element in the first column is 5 multiplied by negative 1 to the power of 4, and the minor, we are going to delete the third row, first column, so we have negative 1, 4, negative 2, 7. Simplify it, we will have 3 times 1 times negative 20 plus 7 plus 1 times negative 1 times negative 10 plus 4 plus 5 times 1 times negative 7 plus 8. It is equal to negative 28. In example 16, given matrix A, find the determinant of matrix A by using expansion of the cofactors. So here we are free to choose any row or any column to expand. But to make it easier for us to calculate, we are going to use any row or any factors that has 0 as the elements. So here, I'm going to choose second row. So the determinant of matrix A is given by A21, C21 plus A22, C22 plus A23, C23. So the element of the second row, first column is negative 3 multiplied by its cofactor. So the cofactor should be negative 1 raised to the power of 2 plus 1, that is 3. Multiplied by its minor. Minor, we are going to delete the second row, first column. So the matrix will be negative 5, 1, 5, negative 4. Okay, plus A22, that is the element in the second row, first column, that is 0. 0 multiplied by its cofactor, so we don't need to find the cofactor because 0 multiplied by any number will be 0. Plus the element of second row, third column, that is 1 multiplied by its cofactor, negative 1 to the power of 2 plus 3, that is 5. So to get the minor, we are going to delete the second row, third column. So the matrix will be 2, negative 5, 2, 5. And then we are going to evaluate it. We will have negative 3 times negative 1 multiplied by 20 minus 5 plus 0 plus negative 1 multiplied by 10 minus negative 10, that is 10 plus 10. The answer is 25. Example 17. Given matrix A, find A, the element of A11, A21 and A31, B, the minor of M11, M21 and M31, and C, find the cofactors of C11, C21 and C31. Hence, find the determinant of A. So we have to be very careful here because there is a word hence here. So that means we are going to use the answer in A, B, C to get the determinant of A. So let's look at the solution. So for question A, we want to find the element of A11. The element of A11 is 1. That is the element in the first row, first column. Okay, A21, the element in the second row, first column is 2. A31, the element in the third row, first column is 8. So B, minor 1, 1. Minor 1, 1 is the determinant of 2 by 2 matrix, where we get by deleting the first row and the first column. So we have matrix 7, 3, 9, 5, which is equal to 7 times 5 minus 3 times 9. This is equal to 8. M21 is the determinant of the matrix where we delete the second row and the first column. So 6, 1, 9, 5, which is equal to 6 times 5 minus 1 times 9, which is equal to 21. Minor 3, 1 is the determinant of the matrix when we delete the third row, first column. So we are left with 6, 1, 7, 3, which is equal to 6 times 3 minus 1 times 7, 18 minus 7, which is equal to 11. And then we are going to find the cofactors C. C11 is equal to negative 1 to the power of 2 times M11, which is equal to 8. C21 is equal to negative 1 to the power of 3 times M21, which is equal to negative 21. And the last one, C31 is equal to negative 1 to the power of 4 times M31, which is equal to 11. Okay, hence we are going to find the determinant of A. So the determinant of A is given by A11, C11 plus A21, C21 plus A231, C31. We must use the element and the cofactor that we have found previously. So this is equal to 1 times 8 plus 2 times negative 21 plus 8 times 11, which is equal to 54. Now consider determinant of a 2 by 2 matrix A, A, B, C, D. So let's use the expansion of the cofactors. So let's say we are going to use the first row. So the determinant of A is given by A11, C11 plus A12, C12, where A11 the value is A. And C11, that is negative 1 raised to the power of 2 multiplied by the determinant of the matrix when we delete the first row and the first column. When we delete the first row, the first column, we are left out with D. So plus A12, A12 is D. Multiplied by the cofactor of 1, 2, so negative 1 to the power of 3 multiplied by the determinant of the matrix when we delete the first row and the second column. So that is C. So here, when we simplify, we have A times D minus BC.